Time is up. Uh, the goal here is that in this topic, in today's paper, in today's session, we are going to discuss mainly three topics. That we'll talk about some important themes from space technology, then from alternative energy, and from nuclear technology. These are the three themes we are going to discuss. In next class, we'll talk mostly about information communication technology, defense technology, and another small topic like material science. And the last we'll talk about biotechnology, health, and basic frontier space science and all, frontier science, all of that. So the goal here is that is how you can also think about which type of topics you have to revise for examination. And I've given certain themes here in the paper, and I have a few more themes which I have to discuss in the session. So just in one of the question, because I found that its answer there is no option which is correct. So I want to make one correction. Which is a question about biofuel, blending biofuel. Question? Okay. So यहाँ पे कोई भी correct answer नहीं है option में. So this is a problem I just saw. I was going through the question, because first statement is not correct. Second statement is also not correct. Third statement is correct. Answer is 3 only. That it can be used directly without any type of modification. But anyways, we'll go to step by step. So some of the themes I wanted to discuss here in space technology. Let me show you that first. I've mentioned very specific few topics. In some topics, I would expect you to go into more detail. For example, topics like NISAR mission, I expect you to know much more details about this mission, or Aditya mission, or XPoSat mission. But for NASA missions or other space agency mission, even if you have a very basic understanding that what they are, that is more than enough. I will get it uploaded on the जो भी जब भी ये YouTube पे upload होगा, right? So, for example, let me show you the questions which we have. So I have 2 questions. There might be 3 questions also. There is a question not on NISAR, but on the technology which NISAR deploys. This technology is called synthetic aperture radar technology. We have to answer this question. What do you think is the answer? Answer is 2 only, right? So, synthetic aperture radar hai, this is a type of technique. Let me show you. I have a PPT on it. So synthetic aperture radar technique hai. It is a type of technique which does not rely upon presence of light by some other source. It first produces its own radio wave. This is very important. Synthetic aperture radar emits radio wave, does not emit visible light. And then when this radio wave is reflected back, it measures that time difference, and based on that time difference, it can calculate distance and it can create a map of a particular area. Okay. So synthetic aperture radar technology is used to create map with help of radio waves. And इसका फिर best amazing part क्या होगा? That because it is not relying upon presence of some other light source, it does not depend upon sunlight. It can do mapping during night, and radio waves, they can cross through cloud cover very easily. So even if you have adverse climatic condition, even then you can do mapping, which is not possible in some other type of techniques such as optical imaging technique, that you are clicking picture from camera. So this will be an example of that you do what is called passive sensing, that there is sunlight, that sunlight is being reflected by a surface, and you are capturing that reflected sunlight. You do not produce, like our cameras, that is how our cameras function, that they capture reflected light, they capture that, and that is how they can develop image, right? So in synthetic aperture radar technology, that is not how it functions. It produces its own wave, and then it measures the reflection. And because it is using radio waves can cross through cloud cover very easily. We do not have to worry about mapping during night. All of these are benefits of synthetic aperture radar technology. Okay. But I can add more layers of information here. because this is a topic which you should prepare in detail, it was launched by ISRO just last year, hardly 6 months ago, 6-7 months ago. So important current affairs, we should know that. So I can add more layers of information. For example, we should know that in which orbit it, in fact, let me show you that second question also. ये क्वेश्चन देखो, इसका क्या आंसर किया आप लोगों ने? How many of the following can be possible applications of NISAR mission? Sorry? It can be used for internet connection in airplanes. It's not a communication satellite. इसका कोई लेना देना नहीं है communication से. So first statement, that does not make sense. It can measure Earth's changing ecosystem. Yes, that is the exact objective of NISAR mission. That it is capable of measuring Earth's changing ecosystem. It can provide information about sea level rise. Yes, that is also Earth observation. It can help in monitoring groundwater resources. That is possible. With help of NISAR, that is possible. It can provide accurate geospatial positioning services in India and USA. कोई लेना देना नहीं है. Even though it is a collaboration between India and USA, it has nothing to do with location part. That is done by GPS or NAVIC. इसका इससे कोई लेना देना नहीं है. It can map entire planet in 24 hours as Earth completes one rotation. Not at all. Earth completes one rotation, but satellite, when it is going to map, so that is why knowing some more details is important. So this satellite is placed in about some 750 kilometer of sun synchronous polar orbit. I will remember that. This is an important fact. ISRO का mission है. I will remember such type of factual detail. It is placed into some 747 sun synchronous polar orbit. Sun synchronous का मतलब यहाँ पे ये है that it can image a particular place all the time when position of sun in the sky is the same. Whenever it crosses above a place, for this satellite, the position of sun in the sky will be the same. The orbit is about 750 kilometer. I will remember that also. I will also remember that for the first time, this is important, for the first time, synthetic aperture radar technology is not new. This has been used many, many times. But for the first time, two different frequencies are being used in a space mission. So I will make a statement, it is first dual use radar technology which has been used by any space agency. So it is a collaboration between NASA and ISRO, we should know this. The goal here is, जो L band has, and those two frequency bands we call them L band and S band. So NISAR, some factual details we can write down here. इसका जो orbit है, that is about some 750 kilometer. I am in round off figure. It should be somewhere close to 750 kilometer. And this orbit is called sun synchronous polar orbit. Because this is such a heavy satellite that it was not launched using PSLV but GSLV. I will remember this also. Such type of factual detail I will not remember for other space missions of other agencies. But because it is a mission of ISRO, I will remember such details also. Why I will remember this? Because generally when you want to go to this height, 600-700 kilometer, you ideally launch PSLV. But this was very heavy and hence we used GSLV for it. Okay. I will remember that this is the first dual frequency synthetic aperture radar technology. And what does that mean, dual frequency? That this uses a frequency which is called L band and S band. That even within radio frequency, depending upon which frequency we talk about, we can use all of this nomenclature. जो L band है, इसका wavelength ज़्यादा है, S band का wavelength कम है. So S band has more frequency, less wavelength. L band has less frequency, higher wavelength. You do not have to remember the exact value of the wavelength, but if I have to mention that, here it will be about some 10 centimeter, here it will be about some 21-22 centimeter. But दोनों का फिर अपना एक benefit है. L band का benefit ये है that because it is less frequency, this can cross through many solid objects which S band may not. But S band का फिर अपना एक benefit ये है that it can provide very accurate information about the surface level information. So for example, इसको ऐसे आप समझ लो, that if you want to understand the canopy of the forest, that S band will be very useful. But if you want to understand that ground despite that forest cover, then that L band is going to be very useful. And the most important part, which is being used again for the first time, that two frequencies gathering information of the same place, but that difference in what is called phase difference, that in itself can tell you some altogether different set of information. This is being used for the first time in the world. So ये जो technology है, together it is called sweep SAR technology. Sweep SAR ऐसे समझ लो that it is flying by above a surface, emitting multiple frequencies, measuring that reflection, and then also measuring that L band का data क्या है, S band का data क्या है, and that difference in itself can tell a lot about that particular place. It is capable of mapping entire planet Earth every 12 days, not 24 hours. Earth complete one rotation in 24 hours. But this satellite at one point of time can map only a small strip. When Earth rotates, it will map some other strip. So the entire Earth will be mapped every 12 days. So वो जो last statement था, every 24 hours, that does not make any sense. And last but not the least, that what exactly is the goal of this mission? So fundamentally the goal is to understand how Earth landform changes due to environmental changes, due to disasters. And this satellite, it's so precise and it has such high resolution that even if those changes are happening by very few centimeters, it can know that, it can measure that. So even if this, let's say, glacial retreat has occurred by 1 centimeter, it can measure that. Sea level rise has increased by a very small millimeter value, it can measure that. That does not mean that it can measure anything. The reason I am saying is that I was teaching this topic in one of the classes and somebody asked a question that can it measure plate movement? That जो plate tectonics का जो plate movement है, no, it cannot measure that. Plate movement will be too slow for this to be measured, right? But if the changes are happening within centimeters, this satellite is capable of measuring that. So anyways, इस question का जो answer है, first, not correct, internet connection, no. If I have to remember something, that from satellite, we can have internet connection, a lot of conversation is happening surrounding Starlink and other such type of program. We'll discuss that in our ICT class. We'll have some questions on that theme. So first is not correct. यहाँ पे जो answer है, second, third, sorry, 6 statement है यहाँ पे. I'm really sorry. 1, 2, 3, 4, 5, 6. There are 6 statements. So in that 6th statement, that first statement is not correct. And then 5th statement is not correct. 4th statement is not correct. This is true, this is true, this is true. So answer will be only 3. But this question has to then change. It will be 1, 2, 3, 4, 5, 6. So I will update that. This is very easy. I hope everybody knew this. This is very, very easy. The answer is space missions to Mars. That ये NASA का एक बहुत ambitious project है. This is called Perseverance rover. I should have a picture of it. Yeah. So rover का purpose ये है that it is roaming on the surface of the Mars, and you can see here is that helicopter. So this helicopter is called Ingenuity helicopter, and why this was a big deal? Because for the first time human beings were able to fly something on the surface of Mars, right? So as of now, NASA has lost contact with this helicopter, but it was able to map going to some height and then providing a larger area simultaneously. But Perseverance rover still is active, and there are thousands of images you can see that what Mars looks like, and it craters, and that Olympus Mons, which is the largest mountain in the solar system, what all of these things look like as part of solar system. So this was an easy question, that these two things, they are related to Mars. Okay, this one, question number 4. I have made it easy, but remember this question could have become difficult if that new pattern was how many of these statements are correct. But I guess in this form it is easy. What is the correct answer? I know that out of these 5, at least, not at least, exactly 2 are wrong. 3 are correct, 2 are wrong. I often say this to students that a lot of times finding correct will be better compared to trying to find incorrect. At least in such type of question where you have a lot of scope of elimination. Finding incorrect may be more difficult. Finding correct will be easier. And in statement वाले जो questions हैं, यहाँ पे बहुत बार काम करेगा आपको. Try to find the correct statement. In statement wise, जो statement वाले question है, if let's say you are analyzing that statement, and you have to see, and you are thinking about that, is it correct or not correct? Then if you are thinking that it is not correct, you have to be very specific in your mind that which part of that statement is not correct. First, and second, you also have to think that if this is not correct, what can be correct? So when you do analysis like this, you will be able to filter out a lot of information and will be able to come to the right answer. It will not help in that new pattern, how many of these statements are correct. But in such type of pattern, it can be very helpful. LiDAR uses laser pulses to measure distances and create 3-dimensional map of terrain and structure, yes, but it can also create 2-dimensional map. So both 2D and 3D map can be created. LiDAR is another example of active sensing, that it uses visible light, laser pulses, often green, red, or infrared also. जैसे अगर थोड़ा सा और मुझे information यहाँ पे LiDAR में डालना हो, so it can also use infrared ready. So, but it is laser pulse. It can see through walls, concrete, and metal similar to X-ray. No, it is visible light. Visible light, infrared, they cannot cross through walls, metals similar to X-ray. So that second statement is not correct. It can penetrate forest canopy and reveal the ground surface beneath vegetation. Is that correct? It is actually correct, because LiDAR uses so many millions of pulses that even if you have very small space between leaves, it will be able to penetrate to the surface and that will be reflected back. Autonomous vehicles use LiDAR for real-time obstacle detection and navigation. This is one of the most famous application of LiDAR. So, fourth is true. LiDAR is ineffective in daylight and can only be used during nighttime operation. Not at all. This is not at all true. It is using laser. The best part about laser is that it can be resolved even in the presence of daylight, sunlight. So even if I know some of the basic definition of LiDAR, right? So for example, I should know that 4 should be correct. That will not help you a lot. You can only eliminate option C. I should know that first is correct. So if I know first and fourth are correct, do I have something? Yeah. I can eliminate C and D. And now I have to choose between 3 and 5. So 3 is LiDAR can penetrate forest canopy, reveal ground surface. 5 is it cannot be used during night time. So that makes it easier, right? So here answer is 1, 3 and 4. A is the correct answer. If you have questions till now, you can ask questions, yes. Okay, that's a good question, and that is why I said that we are using laser here. आप सिंपल सा एक लेज़र बीम आप अमेजोन से भी खरीदोगे, and if I switch on that laser beam, I can not just see the spot, I can see that laser going through that dust particle. Even if I have very bright light, that laser is so intense that it can be resolved. Okay, so that is why LiDAR is useful. It uses laser, not that intense laser, but it uses laser beam. It will be so much brighter compared to prevailing visible light, that despite the fact that it is operating in similar frequency range, resolving it by my LiDAR device will be very easy. So LiDAR also works similar to synthetic aperture radar. It produces laser beam, it measures the reflection. So आपका जो question ये है, that will it get confused between that reflected laser versus other light source? Why it will not be? Because laser will be much more brighter compared to the surrounding source, right? So no, it is very good, it is very effective even during daylight. Okay, any other question? Okay, that's actually a good question, because the fact that Navik has as of now Navik is ineffective, that makes it actually an important question. So how navigational satellite function, we should know this. And we should know the technicality because of the fact that Navik has been in use so much. I have not added that in my theme. That's a good question. I can add that in the theme. So you have to know few things. This, let's say I have a GPS receiver here. This GPS receiver has to receive data from 4 independent GPS satellites. And what type of data? So one GPS satellite, it sends a signal that will be a radio signal. It sends a signal with a very specific time stamp. And what is the time difference when this mobile phone, this GPS receives that signal? We have to measure that time difference. And I have to then multiply that with speed of light. Radio waves travel with speed of light. So that tells me distance. But if only one satellite knows the distance, that is not good. Because let's say I know that there is a place which is 10 meters from me. But I will have to make a circle then, or maybe a sphere in fact. I have to make a sphere and I can be anywhere on that sphere. So that is why I need that second satellite and third satellite and fourth satellite. So it can be shown, it's a very simple calculation, it's a very simple visualization to show that I need distance from 4 satellites to know the precise location where I am, okay? First. Second, to know that distance, I have to measure time very, very accurately. So I wanted to add, let's add one more theme here and let's add this layer of information also. To measure that time, we use something called atomic clocks. And atomic clocks, they rely upon vibration of very specific type of atoms, and you should know this, cesium and rubidium. So remember these 2 elements also, that atomic clocks, they rely upon vibration of cesium and rubidium. That when you give these atoms energy, they go to high energy state. When they return back, they emit very specific frequency, which is independent of temperature, pressure, or other type of things. And one more thing, I can add one more information, that whenever we define units of measurements, जैसे आप सबने ऐसा unit पढ़ रखा है. So whenever we define units of measurement, initially what was the unit? कि आपने कोई length लिया, metallic length लिया, उसको एक container में रख दिया और बोल दिया कि 1 मीटर है. And based on that, you are going to measure 2 meter or 10 meter or 1 millimeter, all of that. But it can change, its length can change depending upon temperature and pressure and all of that. And in our day-to-day calculation, that will not make a lot of difference, but it will make a difference if I do calculation in nanometer and micrometers. So that is why scientists thought that using such type of physical devices to measure standard units is not a good idea. We should use some sort of universal constant. So there are certain universal constants, they do not change, they have never changed. And then with help of those universal constant, we can define our SI unit. So for example, when we define 1 meter right now, then 1 meter ka definition ye hoga that how much distance light travels in 1 by 3 into 10 to the power 8 second. Can we appreciate that? That light jo hai, light ka speed jo hai 3 into 10 to the power 8 meter hai. And in fact, it is not exactly this, it is a little bit less than this. So I can say that the definition of 1 meter is that how much distance light has traveled in this much of time. So the reason I am emphasizing upon this, because that same cesium vibration which is used in atomic clocks is also used in defining 1 second. That what is the meaning of 1 second? When we say 1 second, then what does that mean? How much time has passed? So we define that with help of that cesium atomic vibration. Just an extra fact you should remember, and you should know about atomic clocks. So why our Navik is as of now dysfunctional? Because Navik ka jo plan tha to have 7 satellites. Last year it was clear that only, last year it was clear that only 5 of them are active, and now we know that only 3 of them are active. And the reason is that their atomic clocks are not functioning well. And if atomic clocks are not functioning well, they cannot measure distance. They cannot measure time. If they cannot measure time, they cannot measure distance. And as a result of that, they cannot know location. So coming to answer to your question, to have this, to have that geospatial location, kaun sa point tha? 4th one. I need distance data from 4 independent satellites, and that is what navigational satellite systems do. GPS, GLONASS, Galileo, right? Baidu, that quasi-zenith satellite system, or Navik. Right. As of now, although it is not functional, unfortunately. Okay, yes. Okay, that's a good question. 3 is enough if we are doing this calculation on a plane. And locally, yes, Earth can be assumed to be a plane, that Earth is a plane. But one of the objective of satellite will be to also tell you the height. And Earth is not like exactly the same height. तो पहले तो ये है कि Earth ऐसे भी 3-dimensional object है, and I agree with you that even Earth 3 dimension है, locally तो flat ही दिखता है हमको. So I can assume Earth surface to be a plane. And plane के लिए if I know the distance from 3 points, even that is good. But this is where we come to the relief feature, that Earth does not have the same height everywhere. And we do use navigational satellites even for airplanes. If I go to mountains, I do use navigational satellite there also. So I can show, आपने जो 3 बोला है, that is called triangulation. That happens when I'm on a plane. The 3 circles will intersect at one point. The moment I go into 3 dimension, I will have to use spheres. And then I will have to show that 4 spheres, it takes 4 spheres to intersect at one specific point. So it needs 4 satellites to find the precise location. तीन स्फेयर एक पॉइंट पे इंटरसेक्ट नहीं करेंगे. आप सिंपल से ऐसे सोच लो, थोड़ा सा अगर आप इमेजिन कर सकते हो, सही बोल रहे हो आप, आपका थॉट बिल्कुल ठीक है. ये स्फेयर है मेरा, ठीक है. मैंने आपको बोला कि किसी सेंटर से आपने कोई रैंडम पॉइंट चूज किया, वहाँ से मैंने बोला कि 100 मीटर दूर हूँ मैं, आपने स्फेयर बनाया. तो अब आपको पता है कि आई एम समवेयर ऑन द सरफेस ऑफ दिस स्फेयर. ओके, आई टेक सम अदर पॉइंट, आई टेक अनदर स्फेयर. इमेजिन दैट व्हेन 2 स्फेयर्स इंटरसेक्ट दे विल मेक अ सर्कल. When third sphere makes, that will make 2 points. I bring third sphere, I have a circle, and then a sphere is intersecting that circle. Intersection of sphere and circle, 2 points. And then I need that fourth sphere to get that final point. So, आपका जो point है बिल्कुल ठीक है. On a plane, I need 3 points, distance from 3 points. In 3 dimension, I need distance from 4 points. So that is why I need 4 satellites. Right? So ये भी हम याद रखेंगे that for accurate location, I need distance from 4 satellites. Okay, anything else? देखो ये टॉपिक जब तक यूपीएससी पूछने लिए इंपॉर्टेंट रहने वाला है. ये आदित्य L1 मिशन जब तक आ ना जाए, जैसे गगन पे लास्ट ईयर क्वेश्चन आया फाइनली आफ्टर सो मेनी ईयर्स. So similarly this is a topic which will remain important. What is the answer here? ठीक है, answer is B. Aditya L1 mission is frequently described as being placed in a halo orbit. What does this term refer in this context? The answer is B. So I will remember few more things about Aditya L1 mission. In fact, is there any more statement? Any more question on Aditya mission? Okay, this question also, question number 6, what is the answer? Spacecraft placed in Sun-Earth Lagrangian point, L1 Lagrange point, can observe Sun continuously without any eclipse or interruption. That is true. At the L1 point, the combined gravitational pull of the Sun-Earth provides exactly the centripetal force needed for the spacecraft to orbit the Sun in sync with Earth. Both are correct, and second is correct explanation of statement 1. Answer is A, not B. So the fact that if you do this calculation for Earth Sun, you will find, let me show you, I have a slide on it. If you do this calculation for Earth and Sun, you will find that this Lagrange point L1 जो है, that is about 15 lakh kilometer from Earth towards Sun. So this will not be disturbed either by Earth or Moon. Earth and Moon will never come in between this spacecraft and Sun. And इसका goal ये है continuously Sun को observe करना. So this here is this orbit around Lagrangian point, which I am calling halo orbit. But there is a point, and to have that orbit, whatever centripetal force is required, it is not due to only Earth or due to only Sun, it is the combined effect of Sun and Earth. So this was shown by Lagrange that something like this can occur as long as the object I want to orbit is very small and the two other objects which I am talking about, they are very, very heavy. So think about it, Earth and Sun are very heavy, Aditya mission is very light, it's a very small object. So Aditya mission can find a stable orbit due to both Sun and Earth at 5 points. There are 5 such points in space which can occur, and these 5 points are called Lagrange points. That L1 is very useful for solar observation, and that L2, this is very useful for astronomical observation. We can place telescopes here. There is a question on Webb telescope that is placed around Lagrangian point 2. This is not useful, that will always remain behind Sun. L4, L5 may be in future, as of now they are not being used, but maybe in future they will also be useful. We have to know about L1 and L2 point. L1 point is amazing for solar observation, L2 point is amazing for astronomical observation. L1 point पे आदित्य mission के अलावा, if I have to name one more mission, you should know that it will be SOHO mission of NASA. So one more mission if I have to name, solar and heliospheric observatory mission of NASA. इस type का अगर statement है that Aditya is the only mission around L1 point, that will be a wrong statement. Okay. So, but there are very few missions. There are very few missions which are into this halo orbit. हाँ जी. Mm-hmm. Sorry, can you repeat your question? What is the question? ठीक है. So it is actually moving, not exactly perpendicular, but जो आदित्य है, that is not at L1, it is moving around L1. Anyways, go ahead. Not Sun and Moon, Sun and Earth, in this case. Achha, so you are saying that even though both are true, it is not the correct explanation. The fact that I can be into a stable orbit, that is because of Sun and Earth. The fact that this orbit can exist 15 lakh kilometer away without being eclipsed by Earth or Moon is because of the fact that Sun and Earth together can produce 5 such points. So that is why it is a correct explanation. So whenever we do such type of assertion reason question, we always follow that argument that is statement 2 a cause and statement 1 an effect. So but think about it. अगर एक और चीज हम कर सकते थे, that I could have sent this mission in an independent orbit around Sun. There also it would have orbited around Sun and would have done continuous observation. But we would not have received any data because that will be an independent orbit that will move much more faster. Earth is going to move slower. So even if it gathers some data, we'll never receive it. So that is why that Lagrange point 1, which is due to both Sun and Earth, that becomes important, right? So the fact that such point exists 15 lakh kilometer away, which allows continuous observation, is due to the combined effect of Sun and Earth, right? Okay. So that is why there is a causal relationship. You have a question? Yes. But the fact that we can observe it continuously and receive data, आप ऐसे समझ लो, इसीलिए I will use the same example, that if I go into an independent orbit, then no Lagrange point can occur. So the fact we have Lagrange point is due to both combined effect of Sun and Earth. And that allows us this unobstructed observation of Sun while sending data back to Earth without being worrying about any type of eclipse and interruption. Right, so ये जो point है exist ही क्यों करता है? ये exist करता है because of the combined effect of Sun and Earth, and that is why it is a cause and that first is a statement. If मान लेते हैं एक ऐसा मान लो कि अर्थ का मास कुछ और होता या Lagrange point जो कुछ ऐसा होता अर्थ के बहुत पास में रहता या कुछ इस तरीके का पोजीशन होता कि अर्थ would have crossed around it, then that would have caused an eclipse. But it is so far away and it is orbiting around Lagrange point 1 that Earth is not causing any type of eclipse, Moon is not causing any type of eclipse. So they are causally linked. ऐसा नहीं है कि दोनों independent statement हैं. They both are causally linked. Okay, so that is why answer here will be A. Okay. ये ऐसे क्वेश्चन में होता है बहुत बार. जो सर्टेन रीजन क्वेश्चन है, यहाँ पे जो कॉजालिटी स्टैब्लिश कर रहे हैं, that if both are correct, then choosing between A and B, that can be little bit tricky. Yeah. Parker probe, what is the correct answer? This is not a recent current affairs, frankly. The only reason I have mentioned it here because this is such ambitious in nature that I think we should know about it. Right, so even though it is a mission of NASA, this is such high ambitious mission that we can expect even a dedicated question on it. And the fact that Aditya also is in news, so overall solar missions have been in news a lot. Answer here will be, sorry, what was the answer? Answer is all of the above, that is correct. It became the first spacecraft to fly through corona, which is sun's upper atmosphere. I can add one more statement. It is the fastest man-made object as of now. That no object is traveling as fast as man-made object, as fast as Parker probe. But that is not because of us. We launched it around sun. It is due to sun's gravitational force that its speed has increased so much. So first is true. The spacecraft heat shield is made of carbon composite material designed to withstand intense thermal environment near the sun. That is also true. It aims to study heating of solar corona and solar wind. That is also true. It aims to know everything about sun, dynamic events in corona, solar wind, coronal mass ejection. So all three of them are correct statement. Answer is D. I will remember a very important part of solar probe, Parker solar probe. That it has a very complicated orbit, very high elliptical orbit, which goes very close to corona, comes out, then goes up till Venus, then again will go back little bit deeper into corona, again will come out. So it has a very complicated orbit, but the idea here is that we should be capable of knowing about solar corona while it is traveling inside solar corona. And when temperature is more than 1 million degrees Celsius, but even then we have arrangement to ensure that as long as its temperature is not going above 1400 degrees Celsius, it is going to function. Okay, so this is a topic why I have a dedicated question, and the reason is Aditya mission, frankly, that solar missions have been in news a lot, and we should know about this. This is easy. Question number 8 is very easy. This is XPoSat. The answer is C. XPoSat has 2 scientific instruments, and this question, dedicated question on XPoSat. What is the answer here? Okay, so first is true. It is India's first dedicated polarimetry mission to study various dynamics of bright astronomical X-ray sources. Second is true, that it aims to know more about cosmic objects which emit X-ray. Some of them will be regions around black hole, neutron stars, or very heavy star when they explode. That is called supernova. So second is also true. Third does not make any sense. So first of all, it is in low Earth orbit, but even this statement does not make any sense. It is placed in geostationary orbit so that it can continuously observe the same patch of the sky. In geostationary orbit, you can continuously observe same patch of the Earth, not same patch of the sky. So third statement in any case does not make sense. Answer here is 1 and 2 only. 2 things I will add here. इसका जो orbit है करीब 650 किलोमीटर है, by the way, somewhere around 650 kilometer, that is the orbit. 2 things I will add, that those 2 scientific instruments which I told you, they aim to know more about X-ray sources in the universe and the processes which produce X-ray. And to do that, it is capable of measuring the polarization of X-ray. And I will briefly mention what do I mean by the term polarization. Light is a type of wave, and light is a transverse wave. Transverse wave का मतलब क्या होता है? That whatever is essentially wave का जो propagation direction है और जो wave का oscillation है, they both are perpendicular to each other. So आप imagine करो that this pen represents the wave propagation direction. So whatever wave light is, that can oscillate anywhere in this plane. So anything, any oscillation in this plane will be perpendicular to this particular direction. So if my oscillation is random, then such type of light is called unpolarized light. If that oscillation is very specific in a direction, then such type of light is called polarized light. And measuring the polarization of light can tell us a lot about light and the processes which produced that light. And that is the goal of XPoSat mission. that let's first gather the X-ray coming from distant object in the universe, such as regions around black hole or supernova, measure their polarization, and maybe that will tell us more about the structure and shape and geometry of the source which emitted X-ray, as well as the processes which might have emitted this X-ray. And to do that, there are two scientific instruments it has, and that is POLIX and XSPECT. Okay. Question 10. क्या होगा आंसर? Artemis Accords. The Accords are bilateral agreements between USA and individual countries. This was a reason why India did not sign these accords for many years. Artemis Accords are about outer space exploration in a peaceful manner. The third is true. They establish norms for peaceful space exploration. That is the objective of Artemis Accord. It is not only specific to Artemis mission. I have a question on Artemis mission also. It is not only specific to Artemis mission. It is about larger space exploration for future and how countries can collaborate together in a peaceful manner. And if you go and look at the accords, you will find that they're actually very nice. That ऐसे कुछ उसमें problematic चीज़ कुछ भी नहीं है. The only criticism has been that outer space does not belong to one country. Outer space is part of what is called global commons. So if you talk about some rules and regulations, it should come under United Nations and not under United States. So, but as of now, India has signed it. So that fourth statement is not correct. And that third statement is also not correct. They are not legally binding. Okay. So Artemis Accords are non-legally binding arrangement on all the countries who have signed this. And even India has signed it as of now. First is true. Second is true. Answer here is only 2. B is the correct answer. Okay. I can show you some of the principles of these accords. I should have a slide on it. They are very nice principle. Frankly, कुछ भी problematic नहीं है. Space activities should be conducted for peaceful purposes, should happen in transparent manner. We have to avoid harmful interference. There should be global standards, right? Sharing of scientific data. So there is nothing problematic per se in Artemis Accord, but it is US-led accord rather than UN-led accord. I will remember that, and it is non-legally binding agreement. So even China and Russia, for example, are not signatory of Artemis Accord. I do think that there will be a question on this telescope in prelims in future. वो जब भी आए. One of the objective of this session also is that some of those themes maybe UPSC can ask even in future, if not this year. So यहाँ पे क्या होगा आंसर वैसे by the way? It is only designed to search for planets in the habitable zone of other stars. ये word only जो है that is problematic, right? That makes it not correct. It is positioned in a low Earth orbit for easy access and maintenance. No. This is where I talked, I will go back to that Lagrangian point 2, that this is placed around Lagrange point 2 in a halo orbit. So that C is not correct. It is the first space telescope capable of directly imaging exoplanet. Not at all. Many space telescopes in past have this capability. B is true, that it operates at temperature close to absolute zero to maximize its sensitivity. And I simply wanted to mention few lines about this line here. तो पहला तो ये है that Webb telescope जो है that is 15 lakh kilometer, but in the opposite direction. L1 was towards sun, L2 is opposite to Earth. Same benefit, it will not be eclipsed by either moon or Earth while it does astronomical observation. And then it has a solar shield, and the reason it has a solar shield, in fact I can ask this question from you. Why do you think it has that solar shield, and why does it operate at such low temperature? So, but solar panels हैं, तो why am I blocking my mirrors for that? You are right, solar panels हैं, but I am blocking. In fact, let me tell you, ये blocking इतना powerful है, ये जो solar shield है, ये इतना powerful है that the surface which faces sun, temperature is some 90 degrees Celsius, एंड मिरर जहाँ पे है वहाँ पे ये हमेशा ऐसे होगा, जैसे समझ लो कि ये सन यहाँ पे है और मिरर मेरा बिल्कुल इस साइड है. So this side temperature is 80-90 degrees Celsius. This side temperature is -240 degrees Celsius. Such a powerful temperature difference exists. Why do you think this has been done? So solar panels are there, ठीक है, but that is not the purpose. Interference. आप सही डायरेक्शन में जा रहे हैं, थोड़ा सा और इस पे ऐड करेंगे इंफॉर्मेशन. एक और बहुत इंपॉर्टेंट पार्ट यहाँ पे ये है दैट जो वेब टेलीस्कोप है, दिस इज डिजाइन टू गैदर इंफ्रारेड, not visible light. So Hubble telescope जब आप देखोगे, you all have read about Hubble telescope. Hubble telescope that was designed to gather visible light and a small fraction of ultraviolet light. The problem is that visible light and ultraviolet light, when they travel across cosmic distances, and if they come across in a region where there is a lot of dust and gas, then they can be scattered here and there and their intensity can reduce. So when they reach to Earth, telescopes of Earth, when they gather that light will be not that bright and your image will not have very high resolution. Infrared can cross through dust and gas easily. तो पहला तो ये है कि जो Webb telescope है, this is a infrared telescope. And second reason why we have that solar shield, that when objects heat up, they start radiating infrared. We all have learned this, that when objects heat up, they start radiating infrared. We do not want mirrors' own infrared to interfere with our observation. That if mirrors heat up, they will start radiating infrared. And this telescope is supposed to gather infrared. So we do not want that to happen. We want to ensure that whatever infrared is being gathered, it is coming from distant part in the universe. So this is an infrared telescope, and because of that, such powerful arrangement. This, by the way, solar shield is perhaps larger than this room. It is a huge solar shield to protect the mirror from sunlight. Okay. The last topic of space technology. What is the answer here? Again, some of the missions which have been in news a lot, and maybe you can add one or two more which you might have read in last 1 year or 2 years. For example, you can know about DART mission or PACE mission. There was a mission by NASA called PACE, PACE mission, or DART, DART mission. So maybe you can add one or two more here, which is not in this paper. Europa Clipper to assess potential habitability of a Jupiter's moon. That is true. So Europa is one of the moons of Jupiter, known for huge amount of water subsurface. And if there is water in its liquid form, then scientists will always probe for possibility of life there. So that is the objective of Europa Clipper mission. Artemis, to have a permanent human colony on Mars? No. Artemis is being done into phases. जो phase 2 है अभी launch होने वाला है अगले week, 2-3 अप्रैल को कभी भी launch होगा, आप follow करते रहना news. तो Artemis अभी वापस से news में भी आएगा. The first Artemis का जो पहला part था, that was launched in 2022. It was unmanned mission. A spacecraft called Orion, NASA called it Orion, O-R-I-O-N. A spacecraft called Orion that was launched around moon. It orbited around moon, but did not land on the surface of moon, and there was no astronaut inside it. So that was unmanned mission, which did not land on the moon, but NASA was able to recover it safely back on the surface of Earth. Artemis 2, and this is going to be in news just next 1 or 2 weeks, that Artemis 2 will now carry astronauts, and these astronauts will be again inside that Orion capsule, and it is going to orbit around moon, but it will again not land on the surface of the moon. It is going to return back to Earth. Artemis 3, where astronauts will land on the surface of the moon, and Artemis 4 is that ambitious plan that let's create a permanent base at the surface of moon. In fact, one of the plan was to create a space station around moon, but that plan as of now has been cancelled. But the plan to create a base on the surface of moon by end of this century, NASA has budget and all of that. So I will prepare this. And the Artemis Accords, which I just discussed few minutes ago, they are not specific only to this program. Artemis Accords are about overall space exploration. Okay? So this is going to be in current affairs and you should prepare this. Europa Clipper mission. Jupiter has many moons. Saturn has the largest number of moons, but Jupiter had some of the largest moons in the solar system. In fact, the largest one called Ganymede is also part of Jupiter. And Io and Callisto and Europa, these are the 4 largest moons of Jupiter. And Europa is very interesting because of water and because of possibility of life. Anyone else who can add like some other themes from space technology which rest of you can study, which is important for this year prelims? Anurag, anything? Which one? What was Punch mission? By which agency? NASA का Punch mission for solar probe. ठीक है, आधे आपको कुछ पता है? Any space mission? Okay, so you have few missions. हाँ बोलो. एस्ट्रोनॉमी में हम डिस्कस करेंगे. दैट्स एक्चुअली अ वेरी इंपॉर्टेंट टॉपिक. बजट में जो 2 टेलीस्कोप अनाउंस हुए हैं, जो एक फ्रंटियर साइंस करके एक मुझे डिस्कस करना, आई विल मेंशन दैट, वो है हमारे थीम में. तो बजट में जो 2 टेलीस्कोप अनाउंस हुए, दैट इज एक्चुअली वेरी इंपॉर्टेंट. आई एग्री. ओके, व्हाट एल्स? पंच मिशन ऑफ नासा फॉर सोलर प्रोब. टेलीस्कोप वाला हम डिस्कस करेंगे नेक्स्ट टू नेक्स्ट क्लास में. 3rd क्लास में हम टेलीस्कोप वाला डिस्कस करेंगे. एनीथिंग एल्स? चलो, लेट्स go to the next 2 topics, alternative energy and nuclear energy essentially. I have few questions on that. Sorry. You should know, okay, that's a good question. He's asking is that with respect to Aditya L1 mission, what else we should know? So you should know first its location, where it is placed. You should know the benefits of being where it is placed. You should know what are its objectives. So that's 7 scientific instruments. You do not have to remember the name of those instruments, but you should know the overall set of objectives. So for example, one of the simplest objective it has, that the sun की outermost layers हैं, photosphere and chromosphere. Let's click pictures of them in specific frequencies. That is an objective. Objective is to understand more about solar wind, what they are made of, how much energy they have, as they travel, what type of magnetic impact they have on the interplanetary system. Then it also aims to know more about solar flares, that why do they occur, right, about sunspots, about coronal mass ejection. So you have to know the objectives of Aditya L1 mission along with where it is placed. So we'll prepare this in 2 subheadings, objectives of mission and where it is placed. That in itself can be a important question. Okay. Anything else? जो पूरा एनर्जी वाला टॉपिक है, ऐसे भी इंपॉर्टेंट है हमारे लिए, अभी तो और भी ज़्यादा इंपॉर्टेंट है. यू ऑल कैन अप्रिशिएट दैट. सो डोनाल्ड ट्रंप हैज़ इंक्रीज्ड योर, आपका हेडेक बढ़ गया है, बिकॉज यूल हैव टू नाउ रीड मोर थिंग्स, मोर प्लेसेस एंड ऑल ऑफ दैट. सो दिस इज समथिंग विच यूल हैव टू प्रिपेयर. So when we talk about energy, we have to in any case think about beyond fossil fuel and all. But let me discuss one question before I answer. जैसे ये question मुझे लगता है कि शायद पता होना चाहिए हमको. That ये वैसे तो fossil fuel का ही part है, but I think ये पता इसलिए होना चाहिए because ये बहुत बार न्यूज़ में है. अभी पूरा जो scarcity है उसके कारण बहुत बार न्यूज़ में है. So what do you think is the answer here? बहुत लेंदी क्वेश्चन है, मैंने जानबूझ के बनाया है कि लेंदी क्वेश्चन होना चाहिए. What is the answer? Answer is all of the above. 1, 2 and 3. We come across all of these words a lot: liquefied natural gas, compressed natural gas, liquefied petroleum gas. Okay. And there are differences between these 3 and we should know those differences. पहले तो liquefied natural gas and compressed natural gas दोनों में natural gas है. Natural gas का मतलब मीथेन होता है. Remember, natural gas is methane, CH4, 1 carbon, 4 hydrogen atom. Liquefied का मतलब ये है that we are storing it at very low temperature so that it is being stored into liquid stage. Compressed का मतलब ये है that we are storing it at very high pressure but at normal room temperature. Liquefied करके जब आप store करोगे तो सबसे amazing part ये है कि इसको transport करना आसान है. It can be transported easily. So when gas has to be transported, we do this in form of LNG. When we use it, right, when we use it in many cases, we will do that in the form of high pressure compressed natural gas, because maintaining that very low temperature of -40 degrees Celsius, that is going to be difficult in our day-to-day life devices. So first, LNG and CNG are both forms of natural gas, which is methane, but differ in the method used to reduce their volume for storage and transport. And what is that method? Here it is very low temperature storage. Here it is very high pressure storage. That is the difference. LPG, that is petroleum gas. And we should know into details of petroleum refining also, because this has also been in news a lot. So I do not have a question on it, but I am going to show you that what do I mean by the word petroleum refining. So LPG is composed primarily of propane and butane. That is true. They are heavier hydrocarbons. So for example, compared to methane, propane and butane, their molecular mass is more. Stored as liquid under moderate pressure and ambient temperature. So even at moderate pressure, if you compress it, it will be stored into liquid stage, but pressure will be there. So surrounding temperature same hai, thoda sa pressure hai, and it can be stored into liquid stage. So second is true. Third is also true. CNG is cleaner than petrol and diesel in terms of particulate matter emission, and is used in vehicles through dedicated high pressure cylinder, but has a lower driving range than LNG for heavy duty transport. All of that is true. I don't think UPSC will go into so much of detail in just one statement. But the reason I have mentioned it here, because I want you to know all of that. And in fact, I will add one more information, which is, I do not have a question on it. You should know about a process which has remarkable industrial application called fractional distillation, right? And you should know meaning of this process. So fractional distillation simply means, at its most simple, it simply means that you have a mixture, and in that mixture, whatever that mixture has, those things have different boiling point. And as a result of that, when you heat them up on the same temperature, at the same temperature, one of them will boil more compared to the other. As a result of that, one of them, if it is boiling more compared to the other, that becomes gas. And then you can allow that gas to escape, and the other can be condensed. So if you want to filter a mixture of two things which have similar but not same, like little bit difference in boiling point is there, then you can use this method called fractional distillation. And this method is used in petroleum refining, and this becomes so important for us right now. So in petroleum refining, what you do, that you have, this is called fractionating column, and in that fractionating column, at the bottom temperature will be more, at the height temperature will be less. As a result of that, lot of things here, as they boil, they can still reach and we can condense it, but things which cannot, we can filter them out. So we do it again and again. We boil, we condense, we boil, we condense. And when we do this again and again, we can filter out lot of things. If this mixture has more than two things, even those two things can be filtered out. So when we take crude oil, that crude oil cannot be directly used. So when that crude oil goes through this fractional distillation, then at different height, you maintain different temperature, and then you can recover all of these things separately. So you should know about what this method is, and the fact that we do use this into crude oil. You should also know about the last topic which I just discussed, CNG, LPG, LNG, that ये कैसे same है या कैसे different है. I will not be surprised that if there is a question on these themes in prelims examination. But apart from fossil fuel, जो alternative energy as a theme है वो हमेशा important है, and nuclear energy as a theme हमेशा important है. This is another very lengthy question, but what is the answer? We have this very ambitious mission. जैसे यहाँ पे हम 2-3 चीजें prepare करेंगे. In hydrogen as a source of energy, you will prepare at least 3 things separately. First, you will prepare that how do we produce hydrogen? What are the methods to produce hydrogen? ठीक है? And not all methods are environment friendly. Some of those methods have environmental damage. Some are environment friendly. And we associate that color based on that. Hydrogen always is a colorless gas. Hydrogen का color हमेशा कुछ भी नहीं है. But depending upon method of production, we can assign a color to it, that if it is green hydrogen, it is environment friendly. So you have to remember 3 methods. ठीक है? 3 method हम याद रख सकते हैं hydrogen production को लेके. The first method is called steam methane reforming. जो फर्स्ट मेथड है, this method is called steam methane reforming or natural gas reforming. Remember, natural gas is nothing but methane. So in this case we take methane. ये reaction आपको रटना बिल्कुल भी नहीं है. And you pass it through very high temperature steam, and that produces carbon monoxide and hydrogen, and that carbon monoxide can further oxidize, and that can produce CO2 plus H2. What you need to know that in this process lot of CO2 is emitted. So जो steam methane reforming है, lot of CO2 is emitted. And because of that, if you are using this method to produce hydrogen, then it is not environment friendly at all, because आपका जो carbon footprint है वो बहुत ज़्यादा है, ठीक है. In one industry we use lot of hydrogen. Forget about energy. Apart from energy, where do we use hydrogen? A lot. Fertilizer industry. That fertilizer industry में जो अमोनियम बेस्ड जो यूरिया है, यूरिया बनाने के लिए आई नीड अमोनिया. अमोनिया के लिए जो रिएक्शन चाहिए, बहुत सिंपल सा रिएक्शन है. आई टेक नाइट्रोजन, आई टेक हाइड्रोजन, right? Once scientists knew that plants cannot take atmospheric nitrogen directly, but if that nitrogen is fixed, fixing का मतलब है that if I convert that into ammonia, ammonium ion, then plants can absorb it. And that was, in fact, in a way I would say that this was revolution in agriculture, because before that all agriculture was based on that bacterial fixation by legume crops, and now you have industrial fixation. But to do this, nitrogen को separate करना आसान है atmosphere से. 78% of atmosphere is nitrogen. So nitrogen को separate करना आसान है, but hydrogen atmosphere में नहीं है. तो यहाँ पे जो hydrogen production जो होगा, that will come from that natural gas reforming, and that will emit huge amount of greenhouse gases. And this is why, and by the way, this process, so this reaction happens at very high temperature and high pressure. This process was developed by two scientists, and you should still know their names, because 100 years down the line we still use the same method. It's called Haber-Bosch process. These two people were very infamous in scientific community because they also made some chemical weapons, and because of that, when Nobel Prize was given to them, scientific community boycotted that we will not attend this. But despite all of that, Haber-Bosch process जो है बहुत important है. Even today we use the same process to produce ammonia, and from ammonia, that ammonium based fertilizer, urea. But इसीलिए fertilizer industry का जो carbon footprint है वो बहुत ज़्यादा है. So you'll come across, एक और term मैंने green ammonia करके दे रखा है, आगे question है green ammonia पे. You'll come across this term green ammonia. So green ammonia simply signifies that ammonia production के लिए जो hydrogen है, rather than doing this from steam methane reforming, you are using this other method which is called green hydrogen, and that other method is electrolysis. So the first method, that is natural gas reforming, where methane in presence of steam is producing hydrogen. The second method, this is called electrolysis. In electrolysis, you take water, you allow electricity to pass through this water, and you produce hydrogen and oxygen. ठीक है? I can balance it. We can produce hydrogen and oxygen. But this is an endothermic reaction. When hydrogen reacts with oxygen, that releases energy and produces water vapor. But if I do this reaction in the reverse direction, first of all, it is possible that we can do this in reverse direction, but it is an endothermic reaction. I have to supply energy. And if that energy is coming from solar and wind and hydro, then I can call that green hydrogen. If that same energy is coming from nuclear, I can call that pink or purple hydrogen. Okay? So that is the second method that we can do electrolysis. The third method, there are four methods, but third method which you should know, that is called gasification. In gasification, you start with some carbon. Where can we get easily available carbon? Either from agricultural waste biomass or from coal itself. So if we are doing that agricultural waste gasification, then that is called biomass gasification. And if I'm doing that from coal, that is called coal gasification. In both the process, the simplified version of reaction will be that coal has a lot of carbon, but remember, coal in carbon is not independent in coal. It is part of a molecule, and coal has a lot of impurities. And you do the same thing, you have steam, and that will produce this mixture of carbon monoxide and hydrogen, that is called syngas. This gas is called synthetic gas. It's a toxic gas, and that carbon monoxide can further oxidize to produce carbon dioxide. So this is where we call it gray hydrogen or brown hydrogen or black hydrogen, depending upon which type of coal you are using. So the most famous method to produce hydrogen even today in the world is this coal gasification and steam methane reforming. And both of them, that carbon monoxide will further oxidize, will produce CO2. Both of them will produce a lot of carbon dioxide. And coal gasification will produce many byproducts, and many of them will be toxic. Some of those byproducts can be useful. जो UPSC ने क्वेश्चन पूछा था लास्ट ईयर कि कोल गैसिफिकेशन के जो बाई प्रोडक्ट्स हैं कहाँ पे उसका यूज़ किया जा सकता है, राइट. आई स्टिल डू नॉट नो आंसर टू दैट क्वेश्चन बिकॉज या तो आंसर नन ऑफ द अबव है ना तो ऑल थ्री है. सो द रीजन आई एम टेलिंग यू, आपने अगर देखा होगा 2025 का क्वेश्चन देखना आप, देयर इज अ क्वेश्चन दैट कोल गैसिफिकेशन के बाई प्रोडक्ट्स जो है वेयर कैन बी यूज देम. अब डायरेक्टली उन तीनों में कुछ भी रिलीज नहीं होता है. एक एथेनॉल था, एक यूरिया था, एक आई थिंक ग्लिसरीन था, नाइट्रोग्लिसरीन था, एंड डायरेक्टली इन तीनों में कुछ भी नहीं निकलता है. बट ये तीनों प्रोड्यूस हो सकते हैं फ्रॉम द बाई प्रोडक्ट्स विच आर रिलीज्ड फ्रॉम coal gasification. So again I will have to wait for that answer की that UPSC के हिसाब से वहाँ पे आंसर क्या है. So because directly इन तीनों में कुछ भी रिलीज नहीं होता है, indirectly तीनों हम यूज कर सकते हैं. So anyways, the fourth method is called pyrolysis. As a thumb rule, remember, whenever I use the word pyrolysis, it means thermal decomposition. So I'm heating something, but I'm not adding oxygen. So I'm trying to heat something in the absence of oxygen. Such type of process is called pyrolysis. When you do methane pyrolysis, you take CH4, and when you heat it up, that produces carbon and hydrogen. And this process, if this hydrogen is being produced using pyrolysis, we call it turquoise hydrogen. So all of this color of hydrogen, that simply signifies that how much environment friendly your hydrogen production is. So if you look at this question, I have deliberately made it a factual question so that you remember this. Grey hydrogen is produced from fossil fuel without carbon capture, making it one of the most polluting form of hydrogen production. That is true. It emits huge amount of CO2. Blue hydrogen is produced from fossil fuel but with carbon capture and storage, reducing CO2 emission. This is true. I do steam methane reforming or coal gasification, but I capture that CO2 and I store it somewhere. So that is true. Turquoise hydrogen is produced via methane pyrolysis, where methane is split into hydrogen and solid carbon. This is also true. Pink hydrogen uses solar power for electrolysis and is classified separately from green hydrogen because of its higher cost of production. Not at all. Pink hydrogen electrolysis from nuclear, green hydrogen electrolysis from solar, wind, hydro, geothermal, all renewable energy. So that fourth is not true. First, second, third are true. Answer here is C, only 3. So that is the first part, what you have to know, that how do we produce hydrogen. Second part which you should know is that how do we use hydrogen. तो हाइड्रोजन को यूज करने का 4 तरीका है. एक तरीका ये है कि आप हाइड्रोजन को -250 डिग्री सेल्सियस पे लिक्विड बना दो और उसको रॉकेट में यूज करो. तो देखो रॉकेट के लिए फिर भी वो काम का है, डे टू डे लाइफ में -250 डिग्री सेल्सियस हम नहीं कर सकते. Does not make sense. So if you read about GSLV or LVM3, जो third stage of rocket है, that uses that, this is called cryogenic stage, where we are using liquid hydrogen. Day to day life में it does not make any sense. दूसरा तरीका ये है that you mix this with compressed natural gas, that CNG जो था, मीथेन जो था, उसमें आप 20% हाइड्रोजन मिला दो. as long as it is 20%, आपका जो अभी कंबशन इंजन है, जो CNG कंबशन इंजन है, उसको चेंज करने की जरूरत नहीं है. सेम इंजन है, as long as it is 20%, you do not have to change that engine. But because now I am using 20% of hydrogen as a fuel, आपका जो emission है that has reduced. तो ये दूसरा तरीका है. But third and fourth will be that what if I only want to use hydrogen? I do not want it to mix with anything else. तो दो तरीके और हैं. एक है that combustion engine which only uses hydrogen, does not use petrol, diesel, compressed natural gas, 100% hydrogen. But आपका पूरा का पूरा इंजन डिजाइन अलग होगा. It will be really huge. Can anyone tell me why hydrogen based combustion engine are really huge compared to, let's say, CNG based combustion engine or petrol based combustion engine? If I have to add a technical part, I don't think that UPSC इतना technical पूछेगी, but अगर मुझे कुछ एक technical information यहाँ पे add करना हो, why we are so bullish on hydrogen? तो उसका दो कारण है. पहला कारण तो ये है कि when hydrogen burns, it produces H2O, which is not a pollutant. And even though H2O is a greenhouse gas, remember water vapor is a greenhouse gas. Even though water vapor is a greenhouse gas, as long as I am reducing CO2, it's fine. That water vapor problem will be automatically taken care of. तो पहला तो कारण ये है that no air pollution will help in global warming. दूसरा कारण ये है that hydrogen has very high energy density. Now energy density means, generally when we use this word energy density, it simply means that how much joule of energy by 1 kg of fuel. So if I take 1 kg of hydrogen, that energy density will be more than petrol, diesel, kerosene, whatever fuel you have learnt, सबसे ज़्यादा होगा. Except of course nuclear fuel. So hydrogen has very high energy density in joule per kg. But what if I measure that in joule per liter? Because energy density means some per unit of fuel, how much joule of energy. So if I take that per unit 1 kg, then very high. If I take that per unit 1 liter, then it becomes very low. Why? Because hydrogen has very less density. It is the lightest gas. It has very less density. And now you have to store it at very high pressure. And even though you have 1 kg hydrogen, but it occupies few liters of space. तो जो भी आपका hydrogen based combustion engine होगा, that will be very big. तो ये एक problem है. But yeah, we can do that. We can have hydrogen based combustion engine. इसका efficiency कम होगा compared to the next technology which is more important called fuel cell. एक question है fuel cell पे आपके paper में. Okay, so you have hydrogen based combustion engine. That is the third way how you can use hydrogen. Hydrogen based combustion engine has three problems. First I told you about that storage problem. Second problem is also there, and that is that इसका जो efficiency है वो 50-60% के आसपास होगा. So it will not have that very high efficiency. Third जो problem ये है that when hydrogen burns, it burns at very high temperature. And because it is burning at very high temperature, जो nearby nitrogen है that can oxidize. Atmosphere has 78% nitrogen, so this can cause emission of NO, NO2, which are air pollutants. So hydrogen based combustion engine will, अगर मान लो statement ये हो that कोई भी pollutant release नहीं होगा combustion engine से, then answer will be no. NO जो है release होगा, NO2 release होगा. And this is where the last method becomes the most remarkable one, that is called fuel cell. तो जो fuel cell है, this is a combustion engine. You have hydrogen as a fuel rather than petrol or diesel. This is a fuel cell. Fuel cell, and I have few questions on batteries also. So I'm going to discuss that battery also. So fuel cell in terms of structure and components looks like a battery, but it is not exactly a battery. इसका मतलब क्या है? तो सबसे पहले तो जनरली जब हम बैटरी के बारे में सोचते हैं, I have some rechargeable बैटरी, जैसे लिथियम आयन बैटरी में मुझे लिथियम अलग से कोई स्टोर करने की ज़रूरत नहीं है. ये लैपटॉप का ये जो लिथियम आयन बैटरी है, जब मैं इसको चार्ज पे रखूँगा, देन लिथियम एक इलेक्ट्रोड से दूसरे इलेक्ट्रोड पे एक्यूमुलेट होना शुरू हो जाएगा. अभी डिस्चार्ज हो रहा है तो एक इलेक्ट्रोड से दूसरे इलेक्ट्रोड पे जाके एक्यूमुलेट हो रहा है. सो सेम रिएक्शन कैन हैपन इन टू डायरेक्शन. यहाँ पे आई नीड टू हैव अ कंटेनर विच हैज हाइड्रोजन. Same as combustion engine, I need to have a container. And from that container, hydrogen goes to one of the electrode, anode, and at anode, this hydrogen can split into hydrogen ion and electrons. I can call this proton. Hydrogen ion is proton. If electron has come out of hydrogen atom, only proton is left. There is going to be an electrolyte membrane. This is called proton exchange membrane, which allows protons to pass through, that hydrogen ion to pass through. But electrons are routed through an external circuit. And here I can have my useful electrical device, my bulb, my fan, my laptop, my battery, my train, my ship, whatever it is. But when it reaches to that cathode, I have lot of oxygen in the atmosphere. I do not have to carry oxygen if I am doing this in atmosphere. If I am doing this in space, into deep ocean, then I have to carry that oxygen tanker also. So I have this oxygen from atmosphere. That oxygen here mixes at cathode with electron, with proton, and again it produces H2O. तो यहाँ पे भी जो end product है वो फिर से water vapor ही होगा. लेकिन जो ये बीच का जो intermediate step है, that intermediate step essentially ensures that fuel cell will have efficiency of 80-85%. जो combustion engine है, that will have efficiency of about 50 to 60%. So fuel cell is a remarkable technology. Another remarkable thing about fuel cell is that even though this is like an EV, so imagine a combustion engine, hydrogen combustion engine, like a petrol car. And imagine if I am using that fuel cell in car, then imagine that as a EV. But electric vehicle का भी सबसे बड़ा problem क्या है कि आपको चार्ज करने में लगेगा आधे घंटे, 1 घंटे, 4 घंटे. यहाँ पे मुझे हाइड्रोजन टैंक फिल करना है. It's like filling petrol tank. तो 2 मिनट में मेरा फिल हो जाएगा हाइड्रोजन टैंक. So fuel cell technology is the future of hydrogen as a source of energy. The problem is it is very, very expensive. And the reason why it is very expensive, because ये जो reaction है इसके लिए हमको platinum चाहिए. I need platinum here, which is a very expensive metal. It's a very beautiful grayish color metal, more rare than gold. Platinum जो है gold से भी ज़्यादा rare है. But platinum is a remarkable catalyst, and for this reaction, this catalyst means that your fuel cell is expensive. So this is where the second last part of the discussion, that hydrogen has its own problem. पहला तो ये है कि not all production are environment friendly, first. Second, fuel cells are expensive. Green hydrogen production is very, very expensive. Combustion engine emits NOx, has less efficiency, right? And why we are talking about all of this, and I can give you this homework, that go and read about the objectives of National Green Hydrogen Mission. So the reason why we are discussing hydrogen as a topic in so detail, that please go to Ministry of New and Renewable Energy website, mnre.gov.in, and go to National Green Hydrogen Mission and read the objectives of that mission. I can expect question directly on that also, that which of the followings are objective of National Green Hydrogen Mission. So look at this question. With reference to fuel cell, a hydrogen fuel cell generates electricity through a chemical reaction between hydrogen and oxygen with only byproduct being water vapor. That is true. It is an electrochemical reaction, which is a type of chemical reactions. That's fine. Fuel cell require combustion of hydrogen. यहीं पे गलत हो गया. Fuel cell is not combustion. To generate heat, which is then converted to electricity using a turbine similar to conventional thermal power plant. Not at all. Answer here is 1 only. This is an easy question. What about this question? Question 15 का क्या आंसर मार्क किया आप लोगों ने? अगर मार्क किया है देन आपको एक करना चाहिए मार्क. देखो ऐसे क्वेश्चन ऐसे होते हैं कि थोड़ा अगर मान लो पहली बार भी आप पढ़ रहे हो तो थोड़ा सा लॉजिक लगाना चाहिए, सोचना चाहिए कि अगर मान लो फर्स्ट सही है, लेट्स स्टार्ट विद दिस assumption that first is true, and then see that can second be an explanation of the first, and if you find that, then there is a very high probability that answer will be A. Green ammonia is considered a promising zero carbon fuel for the shipping industry and a key carrier for transporting green hydrogen across long distances. Both are true. अब हाइड्रोजन जो है, I told you हाइड्रोजन is a very light gas. इसको बहुत हाई प्रेशर या लो टेम्परेचर पे आपको स्टोर करना पड़ेगा, बहुत फ्लेमेबल है, लीकेबल है, ऑल प्रॉब्लम्स आर देयर. तो अगर आप हाइड्रोजन को अमोनिया में कन्वर्ट कर लो, तो अमोनिया को लिक्विड बनाने के लिए आपको कुछ आई थिंक -30 डिग्री सेल्सियस चाहिए. कंपेयर टू हाइड्रोजन में आपको -250 डिग्री सेल्सियस चाहिए. एंड अमोनिया से हाइड्रोजन को एक्सट्रैक्ट करना बहुत ईजी है. अमोनिया से वापस हाइड्रोजन एक्सट्रैक्ट करना, दैट्स वेरी ईजी. सो दैट फर्स्ट इज ट्रू. And first is true, and the explanation is statement 2, that ammonia has a higher volumetric energy density than liquid hydrogen and is easier to liquefy and store at manageable pressures, making it more practical for bulk transport. Both are correct, and statement 2 is the correct explanation of statement 1. Attempt किया था, क्या mark किया था, ठीक है, but first is true. बट जो ग्रीन है, अगेन अमोनिया का कलर जो है ग्रीन या ब्लू या नहीं है, बिल्कुल वही है. The word green ammonia, so that is I will go back to that Haber-Bosch process, that you will come across this word green ammonia a lot in newspaper, and green ammonia भी है Haber-Bosch process ही, लेकिन जो हाइड्रोजन है that is not coming from steam methane reforming, that is coming from electrolysis of water using solar energy. So that is called green ammonia, but ammonia is ammonia irrespective of what is the process. कोई भी process से आप बना रहे हो, ammonia का property जो है वो same है. So answer here is both are correct and it is the correct explanation. ये कर लिया हमने. Okay, few questions of nuclear and energy storage technology. The reason why I am talking about this, because there is a lot of focus right now on small modular reactor. उस पे भी एक question होना चाहिए paper में about small modular reactor. There is a lot of focus on small modular reactor, and as a result of that, जो हमारा एक larger plan था, that is called 3-staged nuclear energy program. That larger program is now being sidelined a little bit. And few scientists, they made a statement that ये जो थोरियम abandon करने का जो हमारा जो चल रहा है अभी, this is not a good thing for India's energy future, because India has the largest known thorium reserve in the world. Okay, and Dr. Bhabha also knew it, who envisaged that 3-staged nuclear energy program. And the goal here was that let's try to convert that thorium into uranium. Thorium directly is not fissile. Thorium does not undergo fission directly, but thorium can be converted into uranium, and that uranium 233 can be used for nuclear fission. So thorium cannot be used directly as a fuel in nuclear reactor to sustain a fission chain reaction. Thorium must first absorb a neutron, undergo radioactive decay to become uranium. Both are true, and again the correct explanation is there. Answer here is A. ठीक है, तो यहाँ पे भी आंसर जो होगा हमारा A होगा. But with this, तो एक तो हम small modular reactor हम पढ़ेंगे ही, इस पे क्वेश्चन भी है, but I also highly recommend that please go and revise that very 3-stage nuclear energy program जो है, उसके बारे में भी हमको पता होना चाहिए. So there I agree with you to some extent. मैं आपसे थोड़ा सा एग्री करता हूँ इस बात से, that अगर मैं इसको बहुत टेक्निकली डीप में चले जाऊँ, तो क्यों आंसर तो देखो नहीं कर रहा है कि थोरियम का फिशन क्यों नहीं होता, तो वो तो उसके लिए न्यूक्लियर फिजिक्स हमको करना पड़ेगा, जाना पड़ेगा कि थोरियम का फिशन क्यों नहीं हो सकता. बट फिर भी इग्नोर दैट लॉट ऑफ टेक्निकलिटी. The fact that thorium has to be converted first into uranium, that's a fact, and once it is converted into uranium, that is used as a fuel. So this is fine. For our general studies, this is fine. Answer here will be A. But I agree to you to some extent that it is not answering that thorium जो है उसका fission क्यों नहीं होता. Okay? इसका आंसर जो है चेंज होगा, इसका आंसर होगा 3 ओनली. तो इसमें ऑप्शन कोई है ही नहीं, 3 ओनली. फर्स्ट नहीं है ट्रू. 20% टारगेट बाय 2025, दैट डज नॉट मीन कि ये 1% बढ़ते रहेगा हर साल. ऑल्दो there is a conversation going on that 30% target by 2030. So there is this conversation going on because of again Hormuz crisis, that we should increase this from 20 to 30%. So ethanol, with this you should again go back to the basics of how do we produce ethanol or biodiesel or biogas, and what do we mean by first generation, second generation, third generation and fourth generation biofuel, right? जैसे ethanol बनाने के लिए I need certain type of biomass crop जिसपे sugar content बहुत ज़्यादा है, sugar molecules बहुत ज़्यादा हैं, and under suitable condition एक very specific type of fungi जैसे yeast can be used or some bacteria can be used, and in a process called fermentation that crop can be produced into ethanol. When I talk about biodiesel, so there are 3 biofuels जो हमारे काम के हैं जो हमको पता होना चाहिए. When I talk about biodiesel, वो भी पता होना चाहिए. How is that produced? Who will tell me the answer? Yes, go ahead. How is biodiesel produced? Okay, so we are talking about raw material. Anyone else who can add more? We need now those things. There are certain type of fat molecules, lipid molecules, which are required to produce biodiesel. So in case of ethanol, you need starch, you need that carbohydrate, that simple sugar. For biodiesel, you need cooking grease, you need jatropha. So you need crops which have certain type of biological molecules in large amount, right? So, जो repurposed cooked oil है, that can be used into biodiesel. But biodiesel बनाने के लिए you often first use that biomass along with methanol. Methanol is not directly as a biofuel because methanol is very toxic, right? So we use that with methanol in presence of catalyst, and there is a reaction. I just want you to remember the name of the reaction. This reaction is called trans-esterification. It's a very complicated word, but reaction is actually quite simple, right? So chemistry में भी problem है that बहुत बार complicated से words होते हैं, but reaction is actually quite easy. So that reaction is called trans-esterification. And that trans-esterification produces biodiesel. And then third biofuel which you should know here is biogas, which is nothing but natural gas, methane. But rather than using fossil fuel, we are using, let's say, cow dung, manure, sewage sludge. All of these are examples of methane. And depending upon what is your raw material, if you are using food crop like sugarcane and wheat, then that becomes first generation. If I'm using non-food crop, such as rotting things or jatropha, right, these are examples of second generation. If I'm using algae, then that becomes third generation. And fourth generation can mean two things simultaneously. Fourth generation can mean that I'm using some sort of genetic engineering to modify algae, or it can also mean that I use algae to produce biofuel, but that biofuel will emit some CO2 and I capture that CO2 and I store it. So we call this bioenergy with carbon capture and storage, and it can lead to negative emission. Because think about it, when I burn biomass, I'm not adding new CO2 to the atmosphere. Biomass had captured some CO2 from the atmosphere, I burn it, that same CO2 is released into the atmosphere. So I'm not adding new carbon dioxide to the atmosphere. But what if I remove that atmosphere also? So I have biomass, I have biofuel, I use it, some CO2 is released, but I'm not allowing that to be released back to the atmosphere. So this will cause what is called negative emission. And this technology is called bioenergy with carbon capture and storage. So that also can be considered as fourth generation biofuel. Second, biogas produced from organic waste cannot be compressed and used as a vehicle fuel. Biogas methane है. अब methane again biogas हो, natural gas हो, कुछ भी हो, methane का property methane है. So it can be compressed, it can be used for all sort of purposes. Third is true that when we use this word sustainable aviation fuel, drop-in fuel इसको कहा जाता है. आप इसको directly use कर सकते हो. Once it has become that sustainable aviation fuel, it does not require any type of change. You can use that into existing aircraft engine. So इसका option change होगा, answer will be 3 only here. Okay, this question, 3 statement वाले जो question UPSC ने last year बहुत सारे पूछे थे, इसमें क्या होगा? ये question, अब if you think that statement 1 and 2 is a problem, ये तो और बड़ा problem है. When I made this, देखो ये मेरा prerogative है because ये तो मैंने बनाया है. When I made this, I thought that this answer will be A. So India's energy sector has become exposed to global gas market volatility in recent years. That's a fact. The explanation is India is a major importer of LNG, making its gas supply vulnerable to disruptions in international shipping routes. A disruption to natural gas supply simultaneously affects multiple sectors of the economy. Okay, so I think that even statement 3 can be explanation of statement 1, although you can argue that statement 3 is the effect of statement 1. Right? You can argue that, but I will say that I made this question and that was my answer. That even third statement is in a way explanation of statement 1, that there is a crisis right now, and the crisis का एक larger कारण ये भी है that when LNG disruption happens, then multiple sectors of economy get affected. So because of that, I think that third can be thought of as a explanation of statement 1. And इफ़ यू थिंक कि सर ये ऐसा तो नहीं चलेगा, तो यूपीएससी में भी यही होगा कि वहाँ पे भी आपको ये लगेगा कि यार ये क्या चल रहा है, ए भी लग रहा है बी भी लग रहा है, दोनों सही लग रहे हैं. Okay, some questions on battery. Last few questions on battery. Solid state batteries are considered safer than conventional lithium ion batteries. In fact, let me बैटरी के सारे क्वेश्चंस हम एक साथ कर लेंगे, पहले हम बाकी के क्वेश्चंस कर लेते हैं. 21, this is easy, I guess. क्या आंसर? 21 का आंसर इज बी, दैट जियोथर्मल among renewable energy sources, hydro power, geothermal power, they are reliable. Reliable का मतलब ये है that I can produce energy 24/7. I cannot produce energy from solar during night, from wind when there is no wind. The word baseload means that even when you always need some minimum energy. आप ऐसे सोच सकते हो ना कि कुछ ना कुछ तो चल ही रहा है, हॉस्पिटल्स में मशीन्स हैं वो चल ही रहे हैं, कुछ स्ट्रीट लाइट्स हैं उनको तो लाइट चाहिए. सो यू ऑलवेज नीड अ मिनिमम एनर्जी नो मैटर व्हाट टाइम ऑफ द डे इट इज. सो वी कॉल दिस बेस लोड रिक्वायरमेंट. And base load requirement you cannot fulfill from solar, wind, because there is no solar energy during night. So if you are thinking about renewable energy, then you have to think about renewable energy which you can rely upon 24/7. Hydro power will be one of them and geothermal will be one of them. But बाकी सारे गलत हैं, आप देख सकते हो. आंसर यहाँ पे जो है वो बी है. These three in the sense? Which three? Geothermal, solar and wind. Okay, if it is only about energy production, then solar is the cheapest. In fact, solar as of now is almost as cheap as coal, if it is only about energy production. And why I am emphasizing upon this? Because let's say I only want to rely upon solar energy. Then रात में तो solar energy नहीं है मेरे पास. So now I have to invest into energy storage, into very large batteries. And that makes solar energy very expensive. All renewable energy sources, जो कि variable हैं, it makes them expensive. But if it is only about energy production, then जो है this will be, solar energy will be cheap, then wind and then geothermal. Geothermal will be expensive. ठीक है. अच्छा, by the way, about hydrogen, अगर मान लो एक जनरल सा स्टेटमेंट आया that hydrogen has more energy density than petrol, then mark that correct. Even though if however, UPSC जाएगी नहीं इतने टेक्निकलिटी में, जूल पर केजी इट इज़ वेरी हाई, जूल पर लीटर इट इज़ लेस देन पेट्रोल. जूल पर लीटर में हाइड्रोजन बहुत पीछे है, जूल पर केजी में बहुत आगे है. बट अगर एक जेनेरिक स्टेटमेंट हो, then mark that correct, that hydrogen will have more energy density than petrol. 21 answer here is B. 22, both are simultaneously correct. Both of these statements are simultaneously correct. I can show you the data at the end of the year. I should have a slide on it. ये सब कुछ आपको याद नहीं रखना है. ये 2025 एंड का डेटा है. Total installed capacity was some 510 gigawatt. It must have increased in 2 months. And about 48.4% from fossil and 51.6% from non-fossil. And this is remarkable because अगर आप यही 2 साल पहले का डेटा देखोगे तो this was the reverse, that this was 51%, this was 49%. So आप ये clear एक trend दिख रहा है that even though addition is happening at both of these places, more addition is happening in non-fossil and less addition is happening in fossil. Okay, but that does not mean, देखो एक होता है installed capacity, एक होता है actual energy generation. तो अगर हम actual energy generation की बात करें, so that still comes about 70% from coal, right? So coal contributes to majority of India's actual electricity generation because solar, wind operate at significantly lower capacity utilization. This is true, and this is also true. ये खुद में एक assertion reason question हो सकता था, and answer would have been A. That इसी को मैं 2 statement में बांट देता, answer would have been A. So here answer is both 1 and 2. Another 3 statement based question. यहाँ पे क्या आंसर? ये बहुत ईजी है, यहां पे परेशान नहीं होना है. दैट लास्ट स्टेटमेंट इज नॉट करेक्ट. First, fusion is considered potential transformative long-term energy solution because it could provide abundant clean energy. There are many reasons why fusion is so remarkable. More energy than fission, no nuclear waste, no fear of reactor meltdown, all of those things. One of that benefit is that इसका raw material जो है deuterium है, which we can get from ocean. And uranium mining जो है, that is considered very environmentally unsafe. So statement 2 is correct and also explanation of statement 1. Now in France ये जो tokamak है, जो fusion reactor एक जो बहुत famous type है, this is called tokamak. So in France that international thermonuclear experimental tokamak, that is experiment under construction in France will be supplying commercial electricity. इसका purpose है ही नहीं commercial electricity. इसका purpose ये है that let's see that can we produce energy from nuclear fusion in a sustainable manner. And as of now this has not been completed. इसका construction तो complete हुआ ही नहीं है. This construction will be completed by 2030. Hope here is that by 2032, 2033 fusion will become a reality. So only one of these statement 2 and 3 is correct. That explains statement 1. यहाँ पे answer जो होगा वो C होगा. Okay, 3 stage पे question है अभी. The program was designed by Dr. Bhabha to exploit India's large thorium reserve. That is true. India's prototype fast breeder reactor at Kalpakam was fully commissioned and connected to the national grid in 2022. In 2022, the loading of fuel had started, right? But that essentially was, there was some complication. I talked to actually, in our batch, we had a student who is working at Kalpakam in physics optional batch. And I asked that what happened there. And so there was some complication. Fast breeder reactor is very complicated and things did not work out. So we have to do more experiments to see that how to do it in a safe manner. So the second here, that is not correct. It has not even started producing energy. Forget about integration with power grid. So answer here is going to be 1 only. Okay. This is an important topic. Shanti Act has been passed just few months ago. 3-4 चीजें हम याद रखेंगे. मैंने तो यहाँ पे बहुत कम चीजें दे रखी हैं, but कुछ और चीजें भी आप याद रखोगे. पहला है, it allows private sector companies to participate in nuclear energy research, development, technology deployment for the first time. That is true. So Atomic Energy Act tha, that had clear that private companies will not be allowed. So Atomic Energy Act has been done away with. Second, it provides for the scope of unlimited liability for operator of nuclear reactor in case of serious nuclear disaster, which involves more than 1,000 deaths. Is this true? Not at all. That was the entire reason why this other act, Civil Liability Nuclear Act 2010, that was done away with. Right. So when India-US nuclear deal happened in 2008, a lot of opposition parties said that FDI and foreign companies, what if accident happens and who will be accountable? So a law was passed. And that law made a provision for unlimited liability at any point of time. Right? It's very similar to कि आपने गाड़ी खरीदा, 10 साल चलाया, फिर आप एक्सीडेंट हो गया आपका, गाड़ी खराब हो गया, एक्सीडेंट हो गया, और आप जाके बोल रहे हो ऑपरेटर को कि तुमने खराब गाड़ी दे दिया था मुझे. So it was like that. So it was very clear that कि कोई भी फॉरेन कंपनी फिर इंडिया में इन्वेस्ट करने आएगी नहीं, और आई भी नहीं. ये 2010 के बाद से कोई फॉरेन कंपनी, हमने अलाउ तो कर दिया था कि ठीक है फॉरेन कंपनीज कैन कोलैबोरेट, कैन सप्लाई components of reactor. Nobody came. Nobody was interested in it. This was a unique law made by lawmakers of India, which had no precedence anywhere in the world. And I have read articles in Hindu against this act, and I feel कि कब सुधरेंगे हम, ये हमारा जो intellectual class है वो कब तक ऐसे. So anyways, so finally good senses prevailed. These 2 laws have been done away with. It has allowed private companies, it has allowed foreign companies in collaboration with our domestic companies. But कोई unlimited liability नहीं है, capped है. Liability capped है, depending upon आपका capacity क्या है. Liability अलग अलग है, but आपका जो liability है वो capped है. And ये भी true है. जो Atomic Energy Regulatory Board which existed before, but under this law it has been now given a statutory status. So this is also true. So 2 laws have been disbanded, right? And both of those laws have been replaced by this act. 3-4 most important provisions: that capping of liability, allowing of domestic private companies as well as foreign companies, and legal status to Atomic Energy Regulatory Board. And there is a focus on small modular reactor also under this act. अगर आप act पढ़ोगे, there is a focus on talk about small modular reactor also. And that is why this question is there in the paper, that which of the following correctly describes small modular reactors? What is the answer? I have given it very specific, but उसका कारण है, answer here is D. That small modular reactor में 2 keyword हम याद रखेंगे. पहला तो small है, and small ये 2 तरीके से है. एक तो literally small है, that it will occupy less space compared to a large reactor. And दूसरा इस तरीके से small है, that इसका जो capacity होगा, that will be less than 300 megawatt. Compared to a large reactor, whose capacity can be 5, 6, 7, even 1000 megawatt, which will be 1 gigawatt. So small modular reactor, small word, that is the meaning. Modular का मतलब यहाँ पे ये है, that अभी क्या होगा कि आपने land acquire किया, फिर reactor construction शुरू हुआ, अभी आपने plan किया कि nuclear reactor यहाँ पे बनाना है. Now wait for 15 years. Before that reactor will be ready to produce power. Modular का यहाँ पे मतलब ये है that I can give my order to some company which makes component of that reactor. While I'm doing my land acquisition, I buy those components, I assemble that reactor on site itself. So that is the meaning of the word modular. And benefit क्या होगा कि rather than having one 900 megawatt of one reactor, which will start producing in 15 years, I can have 3 of them at 3 different places, 900 megawatt, decentralized power, and all of that will happen in within 1 and 2 years. So that is the significance of small modular reactor. So Russia has floating small modular reactor, China is doing something, US is doing something, and now India has also provision for small modular reactor to be produced in our country, and that is also part of the Shanti Act, by the way. So answer here is D. Fission reactor with an electricity output below 300 megawatt, designed to be factory built in standardized modules that can be transported and assembled at the deployment site. That is the meaning of the word small modular reactor. It has allowed private companies. Restriction का मतलब ये है that every company, चाहे वो public हो private हो, they will come under purview of Atomic Energy Regulatory Board. हाँ, of course that is there. Okay, आप enrichment जो है, enrichment percentage जो है, enrichment process जो है, that has to happen in a transfer. That's altogether a different thing. एक है कि आपने एनर्जी प्रोड्यूस करना शुरू किया यूरेनियम को, आप इनरिचमेंट कर रहे हो, आप 20-30%, तो फिर आप क्या कर रहे हो? आप चाहते हो क्या कि डोनाल्ड ट्रम्प इंडिया की तरफ आए? सो यू डू नॉट वांट दैट टू हैपन. एनीवेज, या दैट विल बी देयर. हाई इनरिचमेंट पे हमेशा रेगुलेशन होगा, दैट विल बी प्रोहिबिटेड. ओके, क्वेश्चन 27. क्या आंसर करा आप लोगों ने? मुश्किल है क्वेश्चन है, इजी नहीं आई थिंक. And I have deliberately made it because ये बहुत न्यूज़ में है perovskite materials जो हैं, and the answer is D here, 1, 2 and 3. Okay, so let me tell you, there are certain type of crystalline materials जिनका जो molecular structure है उसको हम लिखते हैं ABX3, जहाँ पे A can be one cation, B can be another cation, X will be a halogen, it will be some iodine, chlorine, bromine, something else. And ये जो बहुत सारे molecules हैं which fit into this category called perovskite, right? So it's not one molecule. There are group of molecules in crystalline form which have this molecular structure called ABX3. And the best part about many of these perovskite materials is that they are better at solar absorption compared to silicon. So they can make better solar panels compared to silicon. So ये जो statement है that perovskite silicon tandem solar cell have achieved efficiencies more than silicon based solar panel, that is true. In fact, let me give you some data also, that for typical solar panel only based on silicon, this efficiency is about 15 to 20%. Here the efficiency is more than 33%. So that's a huge difference in efficiency. Second, the primary barrier is their instability when exposed to moisture, heat, prolonged ultraviolet radiation. All of that is true. Third, they use lead, which can be toxic. That is also a problem. So answer here is 1, 2, and 3. Remember, one of the most important application of perovskite material will be in making of solar panel. The last question and one more question, both of them are on battery. Question number 20 and question number 28. 28 का क्या आंसर करा आप लोगों ने? अगेन मुश्किल है, जानबूझ के मैंने दिया है, ऐसा नहीं कि यूपीएससी इतने डिटेल में, ये क्वेश्चन तो आ रहे हैं, वैसे आपने देखा होगा ये जो 3 कॉलम 3 रो वाले जो है तो आ तो रही हैं. The reason I have given this question because you go and read about all of them, all 3 of them, and in fact even more of them. This is a theme, जैसे ऑल्टरनेटिव एनर्जी कैसे भी पॉपुलर हो रहा है, ये जो एनर्जी स्टोरेज थीम है, दिस इज गोइंग टू बिकम पॉपुलर. Why this will become popular? Because whenever we think about integrating more solar and wind, we always have to think about energy storage technology. That how do I produce energy for night if my maximum energy is coming from sun? So the good thing about sun is that at some part of day, it is going to produce much more energy than you actually require. तो रात में सप्लाई जो है 0 है, डिमांड 0 नहीं है. बट दिन में ऐसा होगा कि जहां पे सप्लाई बहुत ज्यादा होगा, वो डिमांड से मेनी टाइम ज्यादा होगा. एंड ऐसे केसेस में फिर यू कैन कैप्चर दैट सोलर एनर्जी. बट ये कहना आसान है, हाउ टू कैप्चर इट, वेयर टू कैप्चर इट, ये मुश्किल है. एंड आई एम टॉकिंग अबाउट कैप्चरिंग एनर्जी फॉर अ लॉन्ग ड्यूरेशन. आई एम नॉट टॉकिंग अबाउट दिस लिथियम आयन बैटरी जो कि 2-3 घंटे, 10 घंटे, 12 घंटे. आई एम नॉट टॉकिंग अबाउट दैट. आई एम टॉकिंग अबाउट कैप्चरिंग एनर्जी फॉर days, even for weeks for that matter, definitely for more than 24 hours. First. Second, I am talking about capturing energy for a city, not for a small device. So how do I do that? And this is where the investment in battery technology, this is a part of conversation, and this topic is only going to become more and more important in coming future. Okay. So एक question आया भी था pumped hydro storage पे. जो pumped hydro storage है, pumped hydro power projects जो होते हैं, वो एनर्जी स्टोरेज का एक सबसे बढ़िया एग्जांपल है. सो लेट मी ब्रीफली टेल यू दैट व्हाट आर सम ऑफ द प्लान्स व्हिच पीपल आर थिंकिंग अबाउट. पहले तो हर बैटरी में कॉमन ये है दैट देयर इज एन एनोड, देयर इज अ कैथोड, एंड देन देयर इज दिस इलेक्ट्रोलाइट एंड देयर इज अ मेम्ब्रेन. एंड बैटरी का फंक्शन सिंपल सा, बैटरी का जो मैकेनिज्म है सिंपल सा है, कहीं पे इलेक्ट्रॉन ज्यादा है, कहीं पे इलेक्ट्रॉन कम है. इलेक्ट्रॉन वांट्स टू ensure that concentration हर जगह same हो, right? So at one of the electrode, higher concentration of electron, at another electrode, lower concentration of electron. This reaction together is called redox reaction, which is shortcut of reduction and oxidation. Okay. So you allow some ions to pass through that electrolytic membrane, but you allow electrons to pass through some external circuit, and in that external circuit you have your device, and you can fulfill your energy requirement. But we are talking about batteries which can fulfill energy for they can store energy for very long duration, and they can store high amount of energy. So some of the typical battery which you might have read, for example, you have lead acid battery, or you have lithium ion battery. 2-3 चीजें चेंज होंगी. हर बैटरी में फंडामेंटल प्रिंसिपल देखो, हर बैटरी में सेम है. 2-3 चीजें जो चेंज होंगी वो होगा कि कैथोड आप क्या यूज कर रहे हो, एनोड क्या यूज कर रहे हो, आप इलेक्ट्रोलिटिक मेम्ब्रेन क्या यूज कर रहे हो. एंड डिपेंडिंग अपॉन ऑल ऑफ दैट आपका जो बैटरी का परफॉर्मेंस है, जैसे बैटरी को हम बहुत सारी चीजों पे मेजर करते हैं. एनर्जी डेंसिटी क्या है, कितना केजी बैटरी है, कितना एनर्जी स्टोर कर सकता है, दैट विल बी द एनर्जी डेंसिटी. बैटरी का शेल्फ लाइफ कितना है, सेल्फ डिस्चार्ज कितना है. लॉट ऑफ बैटरीज दे अंडरगो स्मॉल केमिकल रिएक्शन दैट कॉजेज सेल्फ डिस्चार्ज. डज बैटरी हैव अ मेमोरी इफेक्ट. मेमोरी इफेक्ट का मतलब ये है दैट अगर आप बैटरी को, बहुत सारे बैटरीज में ये होता है कि आपने 50% चार्ज करते रहे आप, राइट, 100 से 50 के बाद वापस आपने चार्ज पे लगा दिया, 100 से 50 बहुत बार आपने किया, फिर बाद में कुछ ऐसा होगा कि 100 to 50 ठीक करेगा, 50 to 0 वो बहुत जल्दी खत्म हो जाएगा, राइट. सबका कारण है, सबका केमिकल रीजन है व्हाई डज इट हैपन. बट we have to then figure out that those type of batteries which do not suffer from these problems. And lithium ion battery is the best one for that. Lithium ion battery has very high energy density. Lithium ion battery has very less self-discharge. Lithium ion battery does not suffer from that memory effect. So that is why you find that lithium ion batteries are so common. But lithium का जो tendency to lose electron वो इतना ज़्यादा strong है that because it can easily lose that electron and that can trigger other chemical reactions, exothermic chemical reactions that can produce heat and that can cause fire. So lithium ion battery are flammable as a result of the fact that lithium has this very high tendency to lose electron. It wants to lose electron as soon as possible. And that is where, so एक जो question था, सॉलिड स्टेट बैटरीज का मतलब यहाँ पे ये है दैट आपका जो इलेक्ट्रोलाइट है जो टिपिकली लिक्विड होता है दैट इलेक्ट्रोलाइट इज गोइंग टू बी अ सॉलिड मेम्ब्रेन. तो लिटरली पहले तो सेपरेट करेगा कैथोड एनोड को, बिकॉज इफ यू हैव इलेक्ट्रिक शॉर्ट सर्किट देन कैथोड एनोड if they touch each other you have suddenly huge amount of flow of electron, lot of heat energy, battery will cause fire. Lithium ion battery में एक और problem है आप, because it produces so much of heat that electrolyte can vaporize. And the moment it vaporizes, that cathode anode, that causes short circuit. We do not want that to happen. So solid state battery में electrolyte जो है आपका solid है, that is acting as a electrolyte and also acting as a barrier between cathode and anode. So it makes battery safer. The problem is that to figure out materials which can act as that and still have very high efficiency, still have very high energy density. So this is where a lot of research is happening. So anyways, solid state batteries are considered safer than conventional lithium ion batteries. Conventional lithium ion batteries contain a liquid organic electrolyte that is flammable and can trigger a dangerous self-sustaining fire reaction. Both are true and it is also the correct explanation of statement 1. So answer here is A. And the last one, some of the examples that what are we thinking about that long-term energy storage. तो एक जो सबसे सिंपलेस्ट थिंकिंग है, जो सबसे पॉपुलर है दुनिया में अभी, बिकॉज ये बहुत ही वेल एस्टैब्लिश्ड टेक्नोलॉजी है, पीपल हैव बीन यूजिंग इट फॉर 100 years नाउ. दिस इज कॉल्ड पम्प्ड हाइड्रो पावर स्टोरेज. आपका एक और होमवर्क आई कैन गिव यू, गो एंड रीड अबाउट टॉप 4 पम्प्ड हाइड्रो पावर स्टोरेज प्रोजेक्ट ऑफ इंडिया. ठीक है, कि इंडिया में कहाँ कहाँ पे है, कौन से, इन विच स्टेट दे आर. बहुत सिंपल सा है, यू हैव एन अपर रिजर्वायर, यू हैव अ लोअर रिजर्वायर. व्हेनेवर यू नीड एनर्जी, right, energy demand बहुत ज़्यादा है, you allow that water to be released, you have a turbine here that produces electricity. So think of this as a battery where when water is being released from upper to lower, that is like discharging, okay. But when I have lot of solar energy, lot of wind energy during day, but मेरा जो demand है उतना ज़्यादा नहीं है, then using that solar energy I can run this pump, and with help of this pump I can run that water back from lower to upper, and I can think of this as a charging. This is like a charging mechanism. So I can store lot of energy with help of pumped hydropower storage. I repeat, this is the most popular and this is where 90% of energy storage project pumped hydropower storage का example है. But people are, but यहाँ पे limitation है, I cannot have reservoirs everywhere. So I have to think about other alternatives also. So this is where concept like compressed air energy is being used. That in you make some sort of artificial repository, underground repository, or maybe some naturally occurring repository, that will be even better. And you compress air with very high pressure with help of solar wind energy when they are into access. And when you actually need that energy, you allow that air to pass through, and compressed air as it passes through have a turbine that is going to produce electricity. So this is like a physical storage of energy. So that is something which can be done. Then there is something called gravity model. Gravity model is very similar to that pumped storage, but rather than using water, let's use heavy concrete, let's use heavy metals. That metals are essentially stored at high altitude, and to send them to that high altitude at some height, you are using pump, and you are running that pump with help of excess solar and wind energy during 12 o'clock, 1 a.m., 1 p.m. And when you need that energy, you allow that to fall down naturally, aided by gravity. And that gains kinetic energy, and that is connected to a turbine, and that can produce electricity with help of a generator. So this is called gravity energy storage. So this is similar to pumped storage, but rather than relying upon water, you are using heavy metallic slabs. Then there is something called thermal energy storage. In thermal energy storage, in a container, you put something which can be heated up at very high temperature in an insulating container, and that object should not degrade easily. So I can have molten salt here, or I can have sand here for that matter. So these objects can be heated at very high temperature, and they can store energy even during night. They will not lose that energy. And during night, I will be able to use that for heat energy or for electricity. So we call this thermal energy storage. And one of that topic which is given in the question, these are called flow batteries, and flow batteries are remarkable. They are amazing. And I will also expect you to remember a very specific element called vanadium. There are few ways to make flow batteries. The best way is vanadium. Vanadium is an element, इसका atomic number 23-24 के आसपास होना चाहिए. आप एक बार confirm कर लेना कि इसका atomic number क्या. Although I don't think ये question आएगा. What you should know about vanadium is that vanadium can be found into multiple oxidation states. I can have V2+, V3+, V4+, V5+. तो vanadium जो है और अलग अलग आयनिक फॉर्म में हमको मिलेगा. तो vanadium फ्लो बैटरी में देखो क्या होता है कि आप जो एनर्जी स्टोर करते हो वो इलेक्ट्रोलिटिक टैंक में करते हो. कि आपका जो एनर्जी स्टोरेज है यू आर डूइंग दैट सेपरेटली इनटू इलेक्ट्रोलिटिक टैंक, और ये टैंक जितना बड़ा है उतना ज्यादा एनर्जी आप स्टोर कर सकते हो. बैटरी में दो चीजें होती हैं. जैसे एक स्टेटमेंट देखो, आपके क्वेश्चन पेपर में एक स्टेटमेंट है, एंड ये इतना इजी स्टेटमेंट नहीं है. That power and energy capacity can be scaled independently. Now, energy capacity means that how much energy you can store. Power means how much energy you can deliver per second. Generally in batteries, these two are very much intertwined together. Lithium ion battery में ये बहुत ज़्यादा intertwined होगा. ये vanadium flow battery में नहीं है. आपको बहुत ज़्यादा energy store करके रखना है, have more and more electrolytic tanks, you will be able to store more and more energy. Which also is a challenge because आपका जो volume है बहुत ज़्यादा होगा, mass बहुत ज़्यादा होगा, but you can store more and more energy. But how much power it is going to deliver, that will be a separate thing. So this is true, stores energy in vanadium based liquid electrolyte in external tank. This is also true, power and energy capacity can be scaled independently. Problem here will be that this is going to occupy a lot of space. But another benefit of vanadium flow battery is that vanadium exists into multiple oxidation state. तो आपका जो cathode and anode है उसके लिए आपको अलग अलग elements की जरूरत नहीं है. आप एक oxidation state cathode पे use करो, दूसरा oxidation state anode पे use करो. One is being oxidized, another is being reduced. दोनों vanadium है. तो जो भी self discharge या बाकी के जो chemical reaction degradation, ये सारी चीजें आपकी नहीं होंगी. So vanadium flow battery is remarkable, and this is another option which people are exploring as large scale energy storage mechanism. First, pumped hydro storage stores energy by pumping water to a upper reservoir when power is surplus. This is true. Established technology currently dominant. This is also true. Okay, ये established है, बहुत पुराना है, बहुत सालों से चला आ रहा है. Compressed air energy stores store surplus electricity by compressing air into underground geological caverns. No chemical degradation. This is also true because this is a physical storage. There is no chemical degradation. All are correct here. Every part is correct here. Answer here is all three. Anyone attempted and got it right? Few of you. And it's always a good idea that if you're not very confident, don't attempt such questions. But the reason I have this question here is that I want you to read more about energy storage also, and not just only about alternative energy. Okay? In the next session, we are going to talk about few more topics. So in today's class, we discussed three themes. We talked about space, we talked about energy, we talked about nuclear technology. And some of the themes I discussed, read more about them by yourself also. Don't just focus upon what is given in this question or what I talked in the class. This can work at some sort of template which can be used for revision in science and technology. In next class, we will talk about ICT ke jo topics hain, AI, blockchain, all of that. We'll talk about that, and we'll also discuss defense and material science, nanotechnology. 3 topics we'll discuss in next class also. Okay? I will see you guys. I think we have a session on Monday. Okay. Any questions, by the way? Sorry, I forgot to ask. If you have any questions in any of the questions, you can ask it here. Chalo, I'll see you guys in the next session.